Okay, good evening. Today we're going to discuss energy. In past lectures, we've discussed that atoms and molecules are always in some degree of constant motion, depending on the amount of energy that they contain. So, how do we define energy? Energy is defined as the ability to do change. Change meaning some sort of change in its environment. An example of that might be when you take a rock and you lift it up in the air. By lifting the rock, you've used energy to lift the rock, and that has changed your environment in a specific way. Energy exists in several different forms, and one thing to remember is that energy never disappears. It simply changes from one type of energy into another. And many times, the energy that is wanted or that we want to use is converted into other forms of energy as well that we don't necessarily want. A major concept to remember here is that energy does not disappear. It's always going to be there, all right, in some form or another. Many times, the byproduct or the waste product, the type of energy we don't want that is produced in the form of heat. And you'll see us revisit that throughout the next few months when we talk about energy. Throughout this year, we're going to classify energy into two separate categories: potential energy and kinetic energy. Potential energy is defined as stored energy based on an object's position, structure, or chemical makeup. Kinetic energy is the energy of motion and may be based on the mass of a substance or object and its velocity, its speed in a specific direction, or the motion of the molecules it is made up of. Now, what does that mean? That means you can determine the kinetic energy of an object based on its mass and its velocity once it's in motion, it's moving. And some substances you may not even realize are moving, but any object or substance that exists has atoms and molecules. And while it may look like it's solid and sitting still, those molecules are vibrating in place based on the amount of energy they have in them. As they gain more energy, those molecules start to move faster and faster and faster. And that may cause a solid object to melt, okay, and eventually turn into a gas. So the motion of the atoms and molecules are also a measure of kinetic energy. Different types of potential energy can be converted into all the various forms of kinetic energy, and vice versa. The energy of motion, kinetic energy, can be converted into potential energy, the stored energy, to be used at a later date. Let's look at some of those examples now. One type of potential energy is called gravitational energy. Gravitational energy increases as a mass or an object moves away from the center of the Earth. So, for example, the higher you go up on the diving board, the more potential energy you have, gravitational energy you have. Or the higher you lift up a rock above the ground, the more gravitational energy it would have. There's also mechanical energy, which can be stored in a compressed spring or compressed gases or a stretched elastic band. If you've ever had one of those airplanes where you have the propeller and it twists, it has a rubber band, and you twist the propeller and twist the propeller, you're stretching that rubber band. And when you release the propeller, that potential energy is converted into kinetic energy of motion, and it starts the propeller spinning backwards, the opposite way that you wound it up. There's also potential energy in the chemical bonds between atoms. When you eat your food is broken down, absorbed by your cells, and inside the cells of your body, the energy in the bonds of those food molecules is released when the bonds are broken. During the chemical reaction we call cellular respiration inside your cells. Nuclear energy, where you have energy stored in the potential of a nucleus or center of an individual atom. And when that atom or that nucleus goes through what we call a nuclear reaction, or it's split apart, a tremendous amount of energy can be released in the form of heat. Let's look at the different types of kinetic energy. Now, we said a moving object has kinetic energy. For instance, when you twisted up that rubber band, you were converting mechanical energy of your muscles and bones into the potential energy of the stretched out rubber band. Okay? If a basketball player or a football player takes a ball and throws a pass, they convert the chemical energy in their cells to create movement of their muscles and bones, and they transfer that motion into the kinetic energy of the moving football or basketball. Another type of kinetic energy is thermal energy. Now, we'll do another lecture on thermal energy, temperature, and heat, but you need to understand that they are all directly related to each other. All right? Thermal energy and heat are directly related to temperature. We can't see individual atoms vibrating, but we can feel their kinetic energies as temperature. Temperature is a reflection of the average thermal energy with which atoms vibrate or move. When one part of an environment is warmer than another section of the environment, or a system or object within it, the thermal energy is transferred between them from the area of higher temperature towards an area of lower temperature in the form of heat. So if we're going to define heat, we would say that heat is the flow of energy from a warmer area or object or substance toward colder ones. So if we were to define thermal energy, we would say that thermal energy is the total amount of energy in an object or a substance or a system based on the movement of the molecules in that object, system, or substance. Sound waves are made through the vibration of the atoms in a medium, meaning the vibration of atoms either in air or water or a solid. Without those present, you do not have sound, because sound is not transferred without the vibration of those atoms. And the last type of kinetic energy that we're going to discuss in tonight's lecture is electromagnetic radiation. Okay? Don't get crazy about the big word. It simply means electromagnetic energy is the same thing as radiation or light energy. You know, this type of kinetic energy could take the form of visible light that you'll see from either the sun or a candle or a bulb, radio waves, microwaves, X-rays. All right? Radiation, whether it's coming from, let's say, a candle or a nuclear power plant, when they split an atom, can travel without having a liquid, solid, or gas present. We also know that the electromagnetic energy, or the radiation of the sun's energy, can be converted into the stored chemical bond energy of glucose molecules, which is a carbohydrate, by plants during photosynthesis. This is where most living organisms on Earth get their energy from. All right, the sun's electromagnetic radiation is used to convert carbon dioxide in the atmosphere and water into a sugar called glucose, which is a carbohydrate, that we in turn eat ourselves, or we eat animals that eat those, and we harness the energy from the sun indirectly. The motion in this type of energy is created by photons that move at all different frequencies. Okay? So you have potential energy that can be converted into kinetic energy, and the kinetic energy of motion can be converted back into the different types of potential energy. And during those conversions, energy is never lost. It just changes into the different forms of potential and kinetic energy. Okay? That's it for tonight. We'll see you tomorrow. Okay? Have a good day.